Today I'm going to share with you about the robust messaging ecosystem that we've built at Wix. But before we dive in, how many of you have ever used Kafka? Please raise your hands. All right, great. And how many of you ever felt overwhelmed by integrating Kafka to your services? Raise your hand again. Some, yeah. We at Wix did feel overwhelmed sometimes. And considering the growth of Wix, onboarding new employees all the time, creating many new services all the time, we wanted to focus on allowing dev simplicity while dealing with all the messaging complexities. Today I'm going to share with you some of the solutions and tools that we have found and developed at Wix, and hopefully inspire you to take some of the ideas. So in Wix, we have decided that all the async traffic is going to go through Kafka. And as much as we love Kafka, and we do, Kafka has its downsides. Kafka has a lot of boilerplating code that you have to write, could be tough to debug, and discovering incidents could take time. And again, we want to allow our developers to focus on the business logic. We want it to be as simple for them, and we want to save the possibilities of them for going wrong with implementing Kafka. When implementing Kafka, there are a lot of implementation complexities, which can lead to errors. It's error prone. So all these complexities can lead to production incidents. I want to share with you a production incident that we had. As you hopefully know, Wix is a platform for building websites. And some of our services are in charge of handling, for example, store orders. And it has to push emails, confirmation emails, start shipping processes, whatever the order service does. And the developers for the stores service were not prepared for the amount of traffic that this Black Friday is going to get. So some stores were really successful. So keys were bombarding, some partitions got stuck. Not stuck, but got a lot of traffic. So lag was growing. Other orders got delayed. In addition to all that, the high traffic caused the DB overload. So some messages were failing, not handled properly. And the manager starts calling the developers. What's going on with the orders? Clients are frustrated. They're calling. Just imagine yourself under a situation like this. You have to go find out which messages are not handled properly. How do you replay them? Do you go to Kafka CLI and reset the group offsets? What's going to happen to the currently running traffic that goes into your topic? You would probably have to go through a dev cycle. You would probably have to push some code. Dev cycle is the flow that I'm going to use this term maybe a few times. So just to make it clear, dev cycle is the flow that the developer has to go through when pushing a new code. He has to write the code, test it, upload it to some build systems, and deploy a new version. This thing can take time. And when you are having a production incident, that's the last thing that you want to do. So with that complexity in mind, I'm going to share with you how we give tools to our developers in order to deal with such situations in no time. We want to make it for our developers as simple as writing a function. And my name is Or Ben Ari. I've been at Wix for more than 7 years. And in my free time, I like to play chess and jump from planes. And I've been a part of the Kafka infra team at Wix. We are the ones who develop all the tools for the backend developer at Wix to use and have a good time while working here. So, as you hopefully know as well, Wix is experiencing rapid growth. We have more than 10,000 consumer groups. We have about 4,000 microservices nowadays. Only last year, the produce rate increased by 67%. We're talking about each year, this number may rise. And we have more than 2,000 partitions, with the biggest clusters having over 70,000 partitions. We have many clusters, different DCs, biggest one over 70K. I will give time at the end of the section. So I don't know how many of you have written a classic Kafka client code. It looks something like this. There's a lot of boilerplating. You have to define a lot of properties, serializers, deserializer. You have this great, I'm being cynic, you have this while loop that does the polling. And when you poll, if you're subscribed to a few topics, when you poll, you do not control the messages that you get. It means from which topics that you're going to get it from. Let's say you're subscribed to a few topics, and one of them is very busy. When you do poll, you don't control from which topic you're going to poll. This can create a situation of what I will refer to as busy neighbor, that one topic has super high throughput, other topics can get kind of blocked. And it doesn't allow you easy way to multi-thread, and you need to handle your own commits. All of that is very, very error prone. It's hard to maintain, especially with all the scale that we've talked about. We don't want to make our developers go through this every time. And again, with all that in mind, we have tried to develop the right tools for our developers in order to have a good time with messaging at scale in Wix. So we've built Greyhound. Greyhound is a client library that every backend developer at Wix knows. This is what everyone uses in order to integrate with Kafka. And in general, Greyhound wraps the Kafka client SDK to do all of this stuff for you. And whenever a service wants to produce or consume, he imports our library to his services. He does a lot of stuff for him. And just in the highest level, it wraps the Kafka client SDK, talks directly with Kafka. Now, how would such a code look like? When you're using Greyhound, we allow you to define a message handler with a callback style function. It's, as you can see, you have a message handler and you get you get the typing out of the box and you define some side effects. When you define this consumer, as you see, you get a super nice and easy API in order to configure some configuration that we're giving. We're doing multi-threading out of the box for you. It means that when you use Greyhound, we have different workers managing different queues for each topic, which allows you to avoid this busy neighbor situation that we talked about before. And you can control the parallelism of this, and we do the commits for you. So all the boilerplating that we've seen before, you don't have to deal with any of that now. When we built this kind of client library, we also wanted to allow more features. We want to make our developers' life as fun as possible. So we have at Wix a dynamic configuration system. It's not something that we're managing. It's something that all of Wix uses. It's a nice UI that allows developers to go into their service in the UI, define some configuration params, and really quickly the pods will restart with the new configurations. We've tried to use this as much as possible with our features to allow our developers to play and tweak with all of the abilities that we give in Greyhound without having to write any code. They just go to the UI, insert the configuration that they want to change, and it's going to happen super quickly. What are some of the features that we give? Delayed consumption is an example. Filter by key allows, if you're having a production incident and a key is bombarding, something goes wrong, you can just enter this configuration and we will filter it for you without you having to write any code. We have rate limiting, which allows you to control the pace which you want to get messages. Retries, DLQ, a lot of stuff out of the box. I'm not going to talk about all of them, but I am going to expand about two really cool features. These features are not complex, but they're not trivial as well. And one of them is retries. Now, the way that we implement retry is, I think it's really nice. I hope that maybe if it's relevant for you, you can inspire the ideas here to take for your own services. Now, feel free to picture and take the ideas. We're not going to sue you, or maybe we will. I didn't go through any PR training before. In general, we allow a service to configure retries and DLQ. Two words about DLQ, for those who doesn't know, it's a topic that is, we produce all the messages that failed all the retries in order for the developers to be able to debug it later, maybe consume this topic later and handle the failed messages. So how it works in general, we create a new topic for each retry. And when handler code fails, it can be due to DB fail, third-party fail, whatever happens, we will produce this message to the retry topic, as many retries as you defined, and at the end to a DLQ if everything failed. In the example that you see here, a service defined one retry and one DLQ, and Ground on startup is going to already subscribe to all the retry topics. And once, in this example, it consumes orders topic, it invokes the handler code. Now, this handler code is the side effect, the message handler that we saw from earlier. It invokes it. If this handler throws an error, we will produce the message to the retry topic and consume it as well, because Ground already subscribed to the retry topic. It's going to invoke the handler code again. If it fails again, it goes to the DLQ. Another cool feature, it's not really a feature, it's like the default behavior of our producing at Wix. This is what we call a resilient producer. This thing is the default behavior in Wix again, and this allows us more resiliency of our producing. Obviously, the last thing that we want is data loss. So we, out of the box in Ground, when you try to produce to Kafka and fail for any reason, Kafka is down. When you work with Confluent, it's never down. And but if there's a network issue or I don't know, Ground is going to upload the message to an S3 bucket. And we have what we call the healer. It's a service that we maintain. This healer reads from S3 and tries to produce to Kafka until success. This ensures us more resiliency of producing. Again, I encourage you to try this on your own. It works great for us. So, how much time do we have? Any questions about this so far?
Library is so the yeah, put in one the later or snip in the question then the video.
Okay. Okay, no problem. I'll be here for questions at the end if you have any. We'll talk about it later for the flow. So, Ground was working great. The consumers were happy. The messages were delivered. But we received a new priority. Came the great year of 2022, and with it, a new priority for cost optimizations. As you saw, our produce rate increases significantly every year, and so does our Kafka bill. And we had to tackle this issue. So we started to research to see what our Kafka bill is growing from. We have a few components One of them is that, again, we used to be, our Kafka brokers used to be on-prem, but for many years now they are on Confluent, and we pay for every byte that is being produced and consumed from Kafka. What we have noticed is that our read-write ratio is about 4 times. This means that on average, every message produced to Kafka is read about 4 times. And as you can see, this consume part of the bill is pretty big. It started to raise questions like, what if we could read only once? Another big part is the CKU. CKU is Confluent units. This is what constructs your Kafka cluster. Each CKU means 3 Kafka brokers, and each of those is what allows you to increase your cluster in a way of throughput, partitions, connections. So we wanted to try and reduce all of these things as much as possible, keeping in mind trying to read only once. This is what brought us to the proxy solutions. The proxy solutions are services that we maintain. And the idea is that our services are going to be the only ones who talk with Kafka. When a service is producing to Kafka, Ground now is going to invoke a gRPC endpoint on our producer proxies, and our producer proxy is going to produce to Kafka. This really helped in the effort of reducing the connections, which was a big blocker when we started this effort. The other part of this proxy solution is the consumer proxy. Now, the consumer proxy is a super cool and complex project that we've been working on the past 2 years. The goal of the consumer proxy is to read only once and distribute to all the services that needs to consume the topic. Super high level, the consumer proxy reads from Kafka, is the only one that reads from Kafka, saves the messages on the disk, and then distributes all the messages to the services that subscribed to this topic via gRPC. This gRPC endpoint is now being exposed by Ground. Now, I'm going to show you this bamboozling diagram. You're not supposed to understand it. It's just to show off how complex building this was. You can take pictures. It's not going to help you. This is enough material for an entire lecture, so you can talk to me. If there are enough requirements, maybe we'll do another lecture just about this. But again, like super high level, we read from Kafka, save on the disk, and then invoke gRPCs for the services that needs to consume this partition. So moving to the proxy solution, introduced new benefits. And I'm not going to talk about all of them, but I want to show you a few. In Wix, we have gRPC infrastructure. This is being maintained by DevOps teams, and this gRPC infrastructure allows gRPC requests to be rerouted between DCs, between regions, if this term is more known. And when we moved to proxy and started to invoke clients' Kafka consumption via gRPC, we were able to benefit from all this gRPC infrastructure that Wix gives us. Again, in like one sentence, how it works, if a gRPC fails, if a service is dead in some region, the gRPC infrastructure will reroute the request to another DC, and now it allows services that are dead in one DC to continue their Kafka consumption in another DC. If they would like to, it's also configurable. Another super cool feature is reduced rebalances. Now, I saw that most of you have worked with Kafka, but I am going to mention in a few words. Rebalances, it when a consumer group has new consumers going up or down, and the partitions needs to be reassigned between the consumers. And we try to avoid it as much as possible. Why? Rebalances are painful. As consumers, consumers usually need to stop for some time in order to allow this rebalancing to happen. And I'm not going to dive into rebalances, but when moving to proxy, the only real Kafka consumers are on the proxy pods. The services are no longer running any active Kafka consumers. They are just a gRPC endpoint. So the only real Kafka consumers are on the proxy pods. And again, in Wix, there is super advanced auto-scaling systems, allow services to be auto-scaled by throughput, by Kafka lag, a lot of really cool features. And this would use to cause rebalance every time a pod goes up or down, because that's how it works. Now, with all the consumers being on the proxy only, and I mean the active Kafka consumers, a service can be auto-scaled as much as it wants, gets a ton of pods up and down, and potentially not experience even one rebalance. This is super cool. The last thing I'm going to mention is the cross-tech stack integrations. Now, we saw the confusing and error-prone Kafka client code that you have to write when using Kafka. And now when working with Proxy, you only have to integrate with two endpoints. One of them for registering consumers. You talk to some of our service to declare, I want to listen to some topics. And another endpoint that you have to expose, which is for handling messages. And in Wix nowadays, we have a few tech stacks. We have Scala, we have JavaScript, there is Go and Python. And in order to integrate with our Kafka infrastructure, all they have to do is integrate with these two endpoints. So it's super cool and super easy for new tech stacks to join. So the proxy was a huge success. The read-write ratio dropped from 3.8 to 1.1. This allowed the... this created a throughput decrease. This allowed us to start a partition deletion initiative. All of that together with the reduced connections allowed us to reduce about 50% of the CKUs. Now, I'm not going to say exact number, but it sums up to be huge amount of money. And also, the legacy way of working with Kafka used to be some code running on the client app, needing some CPU. It runs workers, it consumes, it does a lot of work. It required a lot of CPU that, again, costs a lot of money. We have more than 4,000 services at Wix. Only the CPU that we saved by moving to Proxy sums up to millions. In total, we have managed to save more than 50% of the Kafka bill. This considering the fact that the produce rate increased by 67% this year. So if we wouldn't have moved to the proxy solution, the bill would be even higher. And with years to come, every year the produce rate might increase even more. And the Kafka bill would have been growing significantly. So the proxy was a huge success, but we wanted to go farther. We wanted to give our developers tools in order to meet production incidents quickly. We want to help them have their dream tools and being able to recover from incidents super fast. So we've developed a few tools. They're not all mentioned here. Again, I'm not going to dive into all of them, but all the features that we give, as I mentioned before, are integrated with the dynamic configuration system that we have at Wix. Again, this allows all the changes to be done without going through a dev cycle, so they can be super quick. And another super cool feature that we provide, and it's not only super cool because I built it, it's just really useful. It's what we call an ad hoc consumer. What is an ad hoc consumer? Let's imagine that some messages were not handled properly. For whatever reason, there was a bug in the code, there was some third-party app that was failing and we did not catch the error in the correct way, whatever. We need to replace some messages in a independent, without ground and tools world. You would have to go to Kafka CLI probably, move these consumer group offsets, maybe creating a new group and setting the offsets that you want to consume there. And then you would have to go through a dev cycle, deploy a new version. Once you're done, and how do you know that you're done? Once you're done, you would have to delete this group probably. A lot of work. We allow to do that within a click. We just have an endpoint that you call. You set the group topic that you want to reconsume, the messages time frame or offset range that you want to reconsume. And we will do all of that for you. We will create a new group. We will send the messages that were in this time frame to your service once again. And when you're done, we're going to delete this group. All of this while you continue consuming from latest. You don't stop your consumption for this topic in order to go back. You continue normally, and the new group is going to handle the needed messages. So all of these tools go alongside with super advanced monitoring tools that we give. Each new service at Wix that is being deployed has its own dedicated dashboard. This service dashboard has a lot of useful data. We are in charge of the Kafka consumption part, and Ground is producing for you a lot of metrics, and this allows us to show this really nice graphs and dashboards. You can see for each group topic, the consumption, errors, handling time, lags, all of that. Again, you don't have to do anything. When you deploy a new service, you're going to get this out of the box. Another dashboard that we provide is what we call the client's dashboard. I didn't have place in the slide to show all of it, but it has a lot of all the data that you need in order to debug your Kafka consumption. You can see below you have a lag per partition. So you can super easily go here, see if a few partitions are lagging. Is it one partition? You can see the key distribution. Maybe some keys bombarding. You can see the handling time for keys. So you have slowest keys there, top keys consumed, and you have everything you need to debug your Kafka consumption. This, again, goes alongside with auto alerts that, again, you get out of the box that will trigger you with, for dedicated Slack channel. It would send an alert about lag that's growing for some time, about handling time, about error rate that's increasing. All of this stuff allows you to discover incidents in no time. Now, I want to take you to the incident from the start. To remind you, we had high throughput that we didn't plan. We had messages not being handled properly. We had one key bombarding and causing other keys to experience big delay. All of that with all the pressure, and we had to go through a dev cycle. Probably it would take time. Pressure from the managers and the clients was a big catastrophe. Now let's see how we can handle a situation like this with the tools that we give you. In cases like that, we could the first thing that we could have used was the ad hoc consumer. We could have easily find out through the dashboard which messages were the ones that were not handled properly. Also, before that, even the discovery time would have been super quick. We wouldn't have to wait for clients to call and say, my orders are not being confirmed. We would see a lag growing alert or an exceptions rate alert. So we would discover it quickly. We could use the ad hoc consumer to create a new group to consume the failed messages while continuing to consume this topic, not stopping consumption. We could have set rate limit through our dynamic configuration system, we could set rate limit to control the pace of these groups to not overload the DB again, or stop overloading it immediately. And also we could have used the filter by key in order to filter out a problematic key that causes production incidents. We could filter it in later or deal with it later. Just let's make our production stable. All of that just within a few clicks. So this is what I'm going to show you for today. I hope that I gave you some ideas and inspired you to try some of the solutions that we are using on your own. Thank you for listening. I was Or Ben Ari.